As I mentioned before, mathematicians like to have different forms of relationships to tell them different things. So in this example, we're going to talk about point-slope form. Now, slope-intercept form is great when we have the slope and the y-intercept. However, when we have the slope and any point, we should still be able to describe the line. So that's what point-slope form is good for. So let's look at an example where we have 2 points. Let's say -5, -2, and 7, 8. And let's go ahead and draw that line out. In this example, we could easily find the slope by making that triangle that we've talked about previously. The vertical change, or the change in y, can be found by counting the distance from 8 to -2, which we can get using subtraction. And we find that that distance is 10. And because we're counting from this point to this one, we know that it is in the positive direction. And then we can get the change in x by counting from -5 up to 7, which we can get through subtraction as well. 7 minus -5, or in this case, 12. And so now we have our slope. Our slope is just 10 over 12, which we could, of course, reduce down to 5 over 6. So now we know our directions, but the other thing that we need to describe a line is a starting point. So we kind of know its location as well. But we already have 2 starting points. We have both 7, 8 and -5, -2. So let's be clear. We could use either one of these points because the whole idea of slope is that it gives us directions from any point on the line to another point on the line. So in this case, we'll go ahead and just use -5, -2. And we want to use it to travel to some other point on the line. So I'm going to go ahead and just pick a random point on the line here and call it x, y. And this is kind of a generic way of describing any point. So x and y are both variables, it can change. Well, I know that the slope between these 2 points can be gotten using the same method I did before by finding its vertical change and putting that over its horizontal change. And I can again find that using subtraction. So I'm just going to subtract y minus -2 to find the vertical component. So then I'll just subtract x minus -5 to give me this horizontal component here. Okay, then my slope is just my change in y over my change in x. And I know that my change in y is just y minus -2, or y plus 2. And my change in x is just x minus -5, or x plus 5. So now I know that m, or my slope, is equal to y plus 2 over x plus 5. But wait a second, I already calculated my slope. So I can go ahead and just say that I know that m is equal to 5/6. So let's rewrite all of that. And then I'm going to go ahead and clean up the equation and get x and y on different sides by multiplying both sides by x plus 5, which leaves us with 5/6 times x plus 5 is equal to x plus 5 and x plus 5 divide and cancel to 1. So it just equals y plus 2. And this would be the point slope form of the line. Well, let's look at that in general here. We know that to find the slope, we just take one of the x coordinates and subtract the x coordinate from the other point, and then we take the y coordinate from one point and subtract the y coordinate from the other point. And by doing that same multiplication that I did previously, what we wind up with is our point slope form, which would of course look like this. Y minus y1 is equal to m times x minus x1. So what I'm trying to get across in this video is that point slope form is really just the same equation as the slope of a line. And so if we know a point and we know the slope, it becomes very easy for us to put it into this equation and generalize the equation of that line. In the next video, I'll show you an example where we're given those two things and how we can use that to then just write out the equation of the line.